So again, with problems 13 and 14, we have trig functions being equal to a number. 13 is a fraction, but if you aren't given a fraction, turn it into a fraction by making it over 1. Then you want to remember that you're just going to put these numbers on the, and I'm first going to just say opposite or adjacent or hypotenuse. Between the three sides, you're going to put them on the appropriate ratio. You want to remember that sine is opposite over hypotenuse. So if this is angle A right here, then the opposite side is that vertical piece, and then hypotenuse across from 90 degrees. After you have those two, then you'll use Pythagorean theorem to find the third side. And I'm okay with it if you leave an unsimplified square root, if it does turn into an unsimplified square root. So to find this third side, I'm going to put an X on it and just write an equation for Pythagorean theorem. And you'll have your calculator on you. So with your calculator, I'm going to turn to the answers to see the number 589 under the square root. And I don't want you to give me a decimal number because I want to see that you are using Pythagorean theorem and not just kind of throwing it into something that solves for you. Now, once you have all three sides, then it's a matter of remembering who goes with what ratio. Yes. No. Tomorrow's the test, and I'm making sure you guys are ready for the test tomorrow. I'm going to spend the day making sure you guys are ready, because I didn't feel like we've gone over enough and done enough review to give you a test today. So you got another day to prepare. So then I've got listed here the trig functions you're expected to write the ratios for. So you're showing me that you know that cosine is the adjacent side over the hypotenuse, and that you know that tangent is opposite over adjacent. Then these three are your reciprocals. So you can just use the three that you already have, the fact that you're given the sine and then your cosine and tangent. Just take what's there and reciprocate. So cosecant is the reciprocal of which trig function? Somebody type it in. Cosecant reciprocal of, good. So you're going to take sine 6 over 25 and flip it to 25 divided by 6. Then secant is whose reciprocal? Cow. I know, it's funny. You meant the S, I know. Yeah. So then secant is cosine's reciprocal, so take the cosine and reciprocate that. And lastly, cotangent is the reciprocal of, type it in. Yay, tangent. So you're going to take tangent and write its reciprocal. I don't care if denominators have radicals in them. I'm not expecting you to simplify with your radicals on this test. Then when you go over to number 14, I would recommend that if you see a reciprocal trig function, reciprocate it to the one you know. So we just said that cosecant's reciprocal is sine. So that means that sine is the reciprocal of 4, and it's 1/4. And then you're going to do just like what you did over on the other triangle. Opposite then is 1, hypotenuse is 4. Use Pythagorean theorem to find your third side. And that would be leg squared plus leg squared equals hypotenuse squared. 16 minus 1, so square root of 15. And then write down what those ratios are. And I'll just go to the answers at this point. So everyone feeling hopefully okay with a problem like 13 or 14? And then again, like I said, just because I didn't get it on video, we've done enough with the unit circle and done a lot of practice where I feel like you should have 1 through 12. But I can go over questions if you need me to. I just want to first of all make sure I hit these. So now, next, solving trig equations. Keep in mind your main issue is isolating the trig function. Like I said on Friday, I'm going to stick to simpler ones like 18, where you don't have a squared involved, like 15, 16, 17. But be aware that you are going to be testing on them eventually. I want you to practice them right now. And then in the next unit, we're going to switch from degrees to radian measure. And I will expect you to solve equations like this when that test comes up. Number 11. With number 11, for me, I always look at reciprocal first. Secant has the reciprocal of cosine. So basically, I'm reciprocating the left side, and now I'm going to reciprocate the right side by writing 1 divided by root 2. You want to recognize that this number is the same thing as root 2 over 2, one of the familiar unit circle numbers. Then when you look at your unit circle, and you are allowed to have notes on your test tomorrow, when you're looking at cosine, you're going along what are the x coordinates. X equals 1 over 2, x equals root 2 over 2, ding, 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 and x equals root 3 over 2. And that takes us to the 45-degree angle, and 45 degrees before 360. Trying to see what you guys are writing. Oh, I'm fine with you having a root in the denominator. You can feel free to write your numbers that way. The only reason that I'm making the 1 over root 2 change to not have a root in the denominator is to recognize it as one of the trios, the trio being 1 over 2, root 2 over 2, root 3 over 2, which I'm going to add a square root that's unnecessary to just emphasize that this is a nice little pattern of a trio of numbers. And I can talk about number 10. Okay. To finish this up, 360 minus 45 is 315. And the directions are to use the unit circle just to solve between 0 and 360 only. So you're just giving the answers 45 degrees and 315 degrees. Then on number 10, cotangent is always the one. Tangent is hard enough. Cotangent just makes it egg. So I always immediately reciprocate when it comes to cotangent. So reciprocal of cotangent gives me tangent. And then I'm going to reciprocate 1 over root 3. That means root 3 over 1 or root 3. People have different ways to deal with tangent. And let me find one of my little unit circles. I'm going to erase. I personally prefer to look at tangent as slope. And right now we're looking at root 3. Root 3 is a positive slope. The only positive slopes that the unit circle deals with are this slope of positive 1 and then 2 other positive slopes. The steeper positive slope is for a number larger than 1. The less steep positive slope is for the slope that is between 0 and 1. Root 3 is bigger than 1. That means 60 degrees and 240 degrees are the answers. So that is a way that you can do it. You do not have to do it my way. You may have learned it differently, or you may prefer something else. I want you to use what's going to help you the most. And I'm just trying to provide you with ideas of what you can do. So an alternative would be remembering that tangent is sine over cosine and looking at root 3 over 1. If you remember, that's what it simplified to when we reciprocated. Or perhaps you just want to deal with tangent as is. Like if it's square root 1, it's the first slope. I'm not quite sure what you mean, but I will say that for this one, your tangent is 1 divided by root 3. For this one, your tangent is 1. And for this one, your tangent is root 3. Some people will leave cotangent as cotangent and write it as cosine divided by sine and leave that 1 over root 3 as it was. If the numbers aren't too horrible, you can nicely see that if you divide numerator denominator by 2 in either the tangent form or the cotangent form, then you can see that sine deals with root 3 over 2 regardless of whether you're looking at tangent or cotangent, while cosine is 1/2. I'm going to erase a little bit over here to focus on when the sine is root 3 over 2, that takes me to 2 possible angles. When the cosine is 1 over 2, positive 1 over 2, that takes me to its possible 2 angles, but they only share 60 degrees. If you remember that tangent and cotangent are always 180 across from each other on the unit circle, then you can draw a straight line and connect it over with the 240 degrees, giving us those 2 answers. Do realize that the 240 is coming from if you make sine and cosine both negative, because a negative divided by a negative will still be a positive, and that's what lands you down here, is if they're both negative. So I'm hoping that that helped. If you have more questions, let me know. I'm going to go back over to the practice test. And let's do you want me to do certain problems between 15, 16, and 17? Or just pick one? I want to know if some of you have particular problems you wanted to see. Okay, thank you. 15. I recommend that you might want to, when you see the squared show up, you might want to use a letter instead of the entire trig function. For example, I could let the letter C represent cosine x as a function so that I can focus on the algebra without the trig getting in the middle of it. That means that this will be cosine squared multiplied by 2. So that means I'm going to write it as 2c squared. Minus cosine, I'm just going to write c, and then minus 1. That will give you a better look at how this is going to factor. And I will not make you do factoring on tomorrow's test, but we will be doing that in the test that will be coming up after this. Now, when I'm trying to factor that, I want to take these two numbers, multiply, that makes -2, and then the middle number, -1. Two numbers that add to make -1, but multiply to make -2. And that lets us know how to split up the middle term. So when I look at factoring, it's basically dividing. And I know that I have 2c squared, the squared term, and then the constant term down here in the lower right corner. And then that -c is split up between a -2c and a +1c. And that's what the diamond work was for. Then I'm trying to see what will divide both 2c squared and -2c. And 2c is probably the best option. Okay. If that is what we want to use for factoring, then the number that needs to go over here needs to multiply to 2c to make 2c squared, and that would be c. And the thing that goes here needs to multiply to 2c to make -2c, so -1. And then the number up here needs to multiply to c to give me c, and needs to multiply by -1 and give me -1, so it's 1. And that lets me know the factors are 2c plus 1 and c minus 1. Then to keep going with the algebra, I set each factor equal to 0. And I solve, so I subtract 1, divide by 2. And I add 1 to the other side to get the other one. And this is the end of the algebra journey. Now I go into the trig journey of remembering that c represents cosine of an angle. Now I'm going to go back over to a unit circle, and cosine is -1/2 and 1, -1/2 and 1. I'm going to write it down. And then I'm going to put it on here. Okay. Cosine is looking at the x coordinates of points. X coordinates down the negative x-axis are -1/2, which is the one we are looking for. And then it continues to -√2/2 and -√3/2. With the -1/2, I draw a vertical line for the cosine for that x value, and I find 2 angles. Then I have another one, and that's 1. So when x is equal to 1, I draw a vertical line, and I can see that there is only one point on the unit circle that touches. And if you look at the directions say that we are including 0, but not including 360. So the answer you're going to use is 0 degrees, but not 360, because we don't want to count any of the points on that circle twice. And then I have my answers are 120, 240, and 0. 0. And you can choose to write the degree with it or not. It's not a big deal to me whether you do or don't. So, and there you go. Okay, then 18. Whoop. I can go over 18 again. I'll erase what I have written here. And keep in mind, this is closer to what you'll see on the test. I need to first isolate my sine x. And if you just kind of circle it and pretend that it's one variable, you can probably see the two-step equation solving that you need to do. That you need to first add √2 to both sides and then divide by 2. Then you're ready to move on to the unit circle. So the algebra is pretty quick when you're dealing with trig functions where they aren't squared and you aren't multiplying different factors together. And I'm not bringing those in. I'm only keeping it as a simple trig function with maybe multiplication, division, and maybe addition, subtraction, where you isolate that trig function, just using a two-step process or one step, depending on how it's given. Then you're on your way to unit circle. Sine represents y coordinates, and the y coordinates that are positive go +1/2, √2/2, √3/2. We're on the middle one, and the middle one is what cuts the quadrants in half, and that gives us our 45 degrees and 135 degrees. And I want to repeat that you can use a unit circle on the test tomorrow. Since you're at home, you can use whatever notes you have available to you. Usually when I give a test on this, I will give a unit circle for people to work on, but, well, we're not in normal circumstances, are we? No, we are not. And hopefully we will soon be back to normal. So that was number 18 to give us those two answers. Then was there anything else in particular you guys wanted to see that is 1 through 18? Then know that when it comes to you drawing angles, I don't expect you to draw a perfect angle. I just want you to approxidraw. So 75 degrees. If you know that 90 is here and 0 is here, can you approxidraw 75. Maybe about there. Not perfect, doesn't need to be perfect. Now for you showing that angle of rotation of 75 degrees, you're going to make a solid arc and show that turn. That is the 75-degree turn occurring from the initial side of 0 degrees to the terminal side of 75 degrees. This is asking for a negative angle that is coterminal with that angle. If you subtract 360, you will find a coterminal angle that is negative. So then that will take you to negative 285. And the directions are asking you to sketch the angle of rotation by a solid arc, which was already done here, and sketch the coterminal angle with a dotted arc, dot, 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 and ding, for the negative 285. And then 20 and 21 are similar. I'm going to do 24 with you. With 24, you're trying to find the coterminal angle that is positive and less than 1 full rotation. In other words, between 0 and 360. So I want to take 810 degrees and I want to subtract 360. When I subtract 360, that gives me, and then 450. And that's bigger than 360. So I'm going to subtract 360 again. And that's going to then give me 90 degrees. So your coterminal angle that is less than full rotation is 90 degrees. Then this is asking you to just sketch the given angle only. You're not sketching the 90-degree angle. You're sketching the 810-degree angle. Because I had to subtract 360 twice, I have to go around the circle twice. So I'm going to go round 1, whee, dink, round 2, whee, dink, another 90, whee, and stop. And that shows the 810-degree angle. Then, sketching these graphs, the only things we have left to talk a little bit more about are sketching the graphs of sine and cosine, and also solving right triangles with your calculator. So, are there particular problems you wanted me to talk you through? All right, thank you. With 26, I'm going to draw as we go along. I'm going to start with a standard trig function, a standard sine function, y equals sine x, before it is transformed, the parent sine graph. There's where one cycle is going to go serial upside down, serial right side up. When I multiply outside, excuse me, outside the trig function by -1, that will flip it upside down. So I'm going to erase, well, maybe I should just, okay, I'm erasing. Flipping it upside down will cause it to now first go under the x-axis and then go above the x-axis. So we start with the cereal bowl full of milk, and then we go to the spilled milk cereal. Then we have the multiplication by 2 for the x. Every time something every time x has an operation with it, you do to the graph the opposite operation. That says multiply by 2, you're going to divide by 2. That means that my x-coordinate 360 will be divided by 2, and this graph will finish its cycle in 180. That means that when I divide 90 by 2, I get 45. And so what was going to be y negative 1 at 90, it's now y equals negative 1 at 45. And then so on. 180 divided by 2 is 90. 270 divided by 2 is awkward. Let's go over to 360 divided by 2 to give us 180. So you can basically see it's got to go to its low point halfway between 0 and 90, its high point between 90 and 180, and you have a full cycle of that graph. And this asked for 2 cycles, so that was 1, and here comes the second one. Near, 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 near. Whee! Oh, I didn't mean to erase it. But anyway. Zoom. Okay, there's 26. Now let's take a look at 27. Always deal with multiplication issues before addition subtraction issues. I can see that I have a division by 2, but it is for the x. That means I'm going to take my regular sine function's x coordinates. I'm just trying to draw a quick graph. And I'm going to, instead of dividing x coordinates by 2, I'm going to multiply x coordinates by 2. That means that this high point of 1, which occurred at 90, is now occurring at 2 times 90, 180. Whoop. So, that means that what was happening at 180 of hitting 0 and finishing the cereal bowl that is spilling, double that, and we have a complete spilling of cereal from 0 to 360. Then continue that process. 360 times 2 takes us out to 720, and 270 times 2 gets us to the 540. And then I'm going to draw that out. And I'm getting rid of the parent graph. Okay. Now, actually, I should probably fix that. Okay, that's just dealing with divided by 2. Now, I want to look at the addition subtraction. There's an understood parentheses around that x plus 90. Whatever operation is happening to x, the opposite operation is occurring on the graph. I see plus 90, you're going to subtract 90. That means that the point 0, 0 will be negative 90, 0. The point 181 will be 91. The point 360, 0 will be 270, 0. The point 540, negative 1 will be 450, negative 1, and then 720 at 0 will be 630 at 0, and spilling the cereal, keeping the cereal. And so that red graph is the final graph that you want to have. And if you graph more than one graph, I am fine with that. I can tell which one is which. It's best if you make sure to clarify to me which one is which for your own sake, but there you go. So hopefully you guys are feeling good with that. Did you want to see another one of the graphs? Okay, how are you doing with the triangles? This is something we were working on before Thanksgiving break. Okay, so let's do a couple of those. I will focus on, how about 32 and 35? Okay. With each one of these problems, you want to identify which trig function you're working with. Here's the angle. This is the hypotenuse. This is the leg that is opposite the side that opposite the angle that I'm working with. That means I'm going to work with sine of 48 degrees. And sine of an angle is equal to its opposite side divided by its hypotenuse. First, you have the equation. Write out the equation, and then you can go straight to the answer from there or show a few steps if you want. I multiply both sides by x. And then x is equal to 3.2 divided by the sine of 48 degrees. Use your calculator, and with your calculator, you will get 4.306. And test your calculator before class to make sure you're in degree mode. Then for number 35, you're finding the angle this time. So if you look at it, 31, 2, and 3 are you're given an angle. You're finding a side length. 34, 5, and 6, you're finding the angle given two side lengths. You want to identify the two sides. This is one of the legs. It's the leg that is opposite the angle. And then the other leg is helping to make the angle. It is the adjacent side. And when I think of opposites and adjacents, I think tangent. The tangent of our angle is equal to the length of the opposite side divided by the length of the adjacent side. Then with your calculator, you need to make sure that you have a parentheses around that division, and you're going to use your inverse tangent button on that division. And you need to make sure you're clear how your calculator expects you to input. And the result is 51.22 degrees. And then since I've got this other page up, you can see, actually, did that just not come out? Anyway, if your calculator is unreliable, let me show you another option. If you use Desmos, but I warn you, Desmos defaults in radians. You have to change it to degrees. You can type this in. You have all of your trig functions and your inverse trig functions. Do not worry about the ones that end in H. Don't use them. So the problem we were just looking at, we need to find the inverse tangent of 5.6 divided by 4.5. So 5.6 divided by 4.5, if I'm remembering these numbers correctly. And there you are, 51.215, blah, 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 degrees. So you can use a Desmos program. Just, I want to repeat, when you open Desmos, it always defaults on radians. You have to change it to degrees with the wrench right there. Then let me say that if you were trying to solve for x in number 32, with number 32, we had gotten to the point of this right here, 3.2 divided by the sine of 48 degrees. So you can type in 3.2 divided by, and then you can go over to functions. And that was the sine of, I can't remember, 48 degrees. And there's your answer right there, 4.306. So this gives you a calculator option if you're having any difficulties with the calculator you're using. Are people feeling better about all these problems? Okay, let me do one of the cosines just so that a cosine is done. Do you want to see 28, 29, or 30? All right, 28. For 28, we're going to start with the parent graph of cosine, which would be cosine always starts at the top, goes to the middle, bottom, middle, top in 360. And be careful when you're drawing it. I do not want to see a U shape. I need to see a cereal bowl, but then half a cereal bowl that is spilled and half a cereal bowl that is spilled. When I multiply the outside of the function by -3, I'm multiplying the y values by -3. So y value of 1 is now y value -3. Y value 0 stays 0. Y value of -1 times -3 is now +3. Y value 0 is 0. Y value 1 times -3 is -3. And then I've got my upside down cereal bowl and my right side up cereal bowl. Or I can look at it as half a smile, a full frown, and half a smile. So that's taking care of this piece. The last piece is, it says x plus 45. So we're going to take the x values and we're going to subtract 45. I'm going to first erase the original cosine function. And now I'm taking this result and moving it left 45 degrees. Left 45 degrees is going to be half of a tick mark. So this point is moved left half a tick to the left, and continuing with each of these points. For one cycle, I need to see 5 very clear points when you are graphing your trig functions. I know that your graphs aren't going to be amazingly perfect drawings. Do your best, though. I need to see the difference between a happy face and a sad face where it should be, or a cereal bowl that is filled versus a spilled cereal bowl. All right, then, how are you doing? Are there other problems on this practice test that you need me to talk you through? I recommend that today you go over a blank copy of this practice test. You can just have it up on your computer. You don't need to print it out. Just look at the blank copy. If you go to the Google Classroom page, you can find the practice test and just look at the blank copy and see if you can do all the problems and get them correct. You can just put some scratch work on a piece of paper and then check the answers over in the practice test corrections. Check out the answers and make sure that you're doing it correctly. And I don't see any more new problems asked for, so I'm going to